today, Akash Das, he's the hardware team lead. Like he's the one who's be walking you all through how we can make stuff like small robots or maybe something with something innovative with Arduino. He has made prototypes himself. And if you had seen the lockdown video, like the video that was released in July, I guess, where we had talked about what the members did in this lockdown, everybody's achievement was showcased. So there are a couple of videos which show what he did and all, so you can refer to that as well. But yeah, he's someone who's experienced, who's made stuff, and he'll be walking you through what is Arduino and how to use it to its fullest power. Akash, you can take it from here. And yeah, and everybody here who thinks that the friends might be interested, you can share the meet link, like this link that you used to join, so that they can also learn something.
Thank you, Magdi, for the introduction. So, hello everyone. Good evening. Again, just a little intro from my side. That I am Akash from ECE department. I am a robotics and IoT enthusiast. I am currently interning as an embedded developer in one of the startups. Today, I'll be taking the session on introduction to Arduino. I guess this is for the first time DSC IEM is organizing a session on electronics and hardware. So it's a special day. Thanks to Shwamda and also Magdi for
Yeah,
organizing this
definitely.
event
And maybe
here.
if we get a good response, then he'll be, having more sessions and more
Yes,
YouTube videos.
let me share. Is it visible? Can you please tell?
Yeah, your screen is visible.
So let's get an idea about what we are going to cover today. We'll learn about Arduino, types of Arduino boards, variation of their uses, dive into details of Arduino Uno, and then the software that we'll be using for coding the microcontroller, and more things we'll learn as we go. Robotics is the buzzword that we hear many a time. But what is a robot? A robot is a machine which can sense, think, and act accordingly to the instructions that we give. So for this, we need a brain. A brain generally is a microcontroller. A microcontroller is a circuit board that has a chip on it and can be programmed to do many different tasks, like reading info from the sensors and do a certain work. For example, we can use, let's say, a sensor. It's called a photoresistor or LDR. We can use that to find the intensity of light and can control the intensity of the light in the room. Or we can use some sensors to detect the motion and can send alerts. We'll be discussing more on these projects or these things in our sessions of IoT, I guess. Arduino is an easy-to-use 8-bit microcontroller which is based on Atmega 328P. This 8-bit microcontroller, this means that at one single time, Arduino can take input of 8 bits. This is a low power, thing that Arduino is, but STM32 or some boards microcontroller like this, they are 32 bits. Not only do this Arduino company provides hardware, but also an IDE, which makes the whole thing beginner friendly. This is one of the reasons that Arduino is so popular and significant in the electronics world. So this is the thing why we are using Arduino. The second most advantageous is that it is open source. You can get to see the internal circuit design and the diagram or every details that Arduino uses, both the board and also the software from their Arduino official website. And you can also, the fun fact is that you can also make your own board and can use it. And it's very legal. It is programmed in C or C++, and it's really convenient for the beginners and the learners. To our next slide. So Arduino was created for the hobbyist or the beginners, but with time it took big shape and is now an integral part of the modern electronics. So they have produced a number of boards as per the requirements, as per the memory shape, as per the architecture or the design of the robots or anything that you design. From here, this Arduino Uno that you see here, I think my cursor is visible. Arduino Uno that you see, this is the most popular and most easy to use. Then this Arduino Lilipad, the thing that is in the middle, it is used in the wearables like Fitband or smart watches like that. It is designed like this, and it is very small. It is very small and it is compact. Arduino Mega is a bigger version of Arduino Uno. It has some 54 digital input output pins. It is just a bigger version of Arduino Uno with a higher memory space Last, say about this Arduino Nano. This is also used in wearables. I have used this many a times, Arduino Nano, and it is compact. I was making one insect board that was very small, and I used this Arduino Nano in that, and it is really very compact and easy to use. Also like that Arduino Uno. So thus we can select. We can see that we can select the suitable boards for our projects. There are many clones of Arduino since it is open source. And then I told that the fun fact is that we can make our own Arduino board, and we can use it in our projects. Like there are many boards like Arduino Uno Rev 3 is one of the clone that is made. Then there is another board called Arduino Uno Red board. That is also a Chinese clone, I think, of Arduino. Okay, now we'll learn Arduino Uno in a little detail. So you can see the pin diagrams are all and the other specific pins of Arduino in this picture. So from the first, there are many things that is used here. So first one is number one is the reset button. This reset button is used to reset the whole MCU. If sometimes it hangs, there is many cases that when you are doing a heavy work or heavy instruction you have giving, there are many times that Arduino gets hanged, and the reset button helps at that moment. The second one is the AREF. This is the analog reference pin. Actually, Arduino, the output that it gives is 5 volt. By using this analog reference pin, what you can do, you can refer voltage. You can give an analog reference to a voltage. Like you want your output at 3.3 volt, you can give a 3.34 volt using a voltage regulator at analog reference pin, and it will show up in all the pins. That's the thing. That's the usefulness of analog reference. Third one is the ground pin. From the name itself, you can understand that it kind of grounds the connections that you need in an electronic connection, that you need to ground the circuit. These things are the digital input output pins. Digital input output pins, they gives only these 1 and 0 values. They do the processes inside the memory inside the MCU and gives output of 1 and zeros. Now number 5 is the one of the interesting thing, PWM. If you see closely, you can see that in pins 3, 5, 6, 9, 10 and 11 there is a small curve. This means these pins are the PWM pins. PWM, the full form is pulse width modulation. Arduino don't have any digital to analog converter. So it uses these PWM pins to convert the digital values to analog values, like the sequence, like changing the sequence and the frequency of the input of the outputs. Arduino changes the digital value to analog. I'll say about this in the digital session of Arduino. I'll show a diagram and tell about the duty cycle and other things. It will be easier for at that time. So this is very important pins. These PWM pins are really very important. USB connection. It is for the connecting your Arduino board to the your laptop or anything or your PC for burning the code or also the power supply. This 7 number pin is also one of the important pins, TX and RX. TX and RX pins are used for communication with another device. TX means transmitting pins and RX means receiving pins. So when you connect a device, you connect the RX of that device, that receiving of the pins of the device to the transmitting pin of Arduino and vice versa. So in this way, it communicates with the device. It's one of the process of communication. There are many processes of Arduino communicating with other devices. 8. This is the Atmega microcontroller. This is the actual microcontroller that is there inside the Arduino, or say the brain of this board. This Atmega that I referred in the very beginning, Atmega 328P. Now 9 is the power LED. When when you connect this Arduino board to your laptop, or you connect the battery to the Arduino, you see here orange and a green light glowing up. These things for the Arduino um, LED indicator, for power LED indicator. Arduino has a 5-volt voltage regulator to convert all the noises or all the voltages that is coming inside to 5 volt, so that it does not waste or it does not destroys the board. But because for electronics it is very much important to control the voltage or to control the current, because just a few increase of few millivoltage or milliamperes can damage the whole board. Yes, and it has happened with me a many number of times, and yes, and it's really frustrating. So before giving power, we need to regulate the voltage to a perfect voltage that is required by the board. Number 11 is the DC power barrel jack. This one is used when you want to use Arduino as a mobile device. Like when you are making a bot, let's say you are making a obstacle avoider car, let's say, you cannot connect your USB to the laptop because it needs to move. So you connect a DC voltage source from 5 volt to I guess 10 volt. That's the maximum thing you can connect to this power DC power jack, and it can be used as a power supply to the board. So number 12 is the 3.3 volt regular here, 3.3 volt pin. If anyone have the Arduino board, you can see that here is the 3.3 volt pin, then the 5 volt pin, and there are two ground pins. 3.3 volt gives the output of 3.3 to the devices that you connect to the Arduino board, and 5 volt gives output of 5 volt to the devices that you connect as per your requirement. Not all devices use 5 volt, and there are also cases that 3.3 volt is not used by many devices. Number 15 is also one of the important pins of Arduino. That is the analog pins. Analog pins. Because these analog pins, they read the voltage. Let's say I was talking about the photoresistor in the very beginning. I was talking about for controlling the intensity of light. Now this intensity is a value that is that can vary from 0 to like 500, like this. It can vary. It does not have any separate or individual values like zeros and ones. So it can vary from zeros to 500. So this photoresistor is connected to these analog pins, by which what it does, it reads the voltage coming at that pin, and it uses ADC, that is the analog to digital converter, to convert this analog voltage into digital and use it for processing. Yes, I'll tell about these analog pins in great details in the analog sensors session. This is it about the components of UNO, and there are something more, like this is the crystal oscillator that runs the clock. Every microcontroller needs to have a clock for synchronizing the data or for synchronizing everything that is happening inside it. So this thing is the crystal oscillator. If you have any Arduino, you can see that it is written as 16.000. That is the frequency, 16 megahertz crystal oscillator. So this was it about the components of Arduino Uno. Now for the power supply. As you can understand, the power supply, as I said, that power supply is really very important, very significant thing in electronics. the power or the voltage that you supply, because a little increase or increase of voltage or current can just damage every electronic components that is there. So we can use a adapter, we can use a USB cable with the laptop to power our board, or we can use a DC supply like this one, the DC power battery. We can use it also to make the Arduino board mobile. Now this is for the Arduino IDE. This is the software that we use to program our or to burn the code into our microcontroller. It's a user-friendly programming environment. You can download the software from the official Arduino website, that is arduino.cc. You can download the software. So let's discuss some of its features. This white area, this is the programming part, and this is the output or the output console, where you can see the errors or the things that you have done. This is the this option is for the compiling the code or verifying the code, is it right or is it okay. Or the second one is the upload. By this you can upload or burn the code that you have written into your microcontroller board. These are the things that is familiar with everything new, open and safe, you can understand. Now let's discuss about the programming workflow, that what it actually follows. It is also very user friendly. The structure of program has been made very simple for beginners. Program workflow is like that: it first initialize the whole thing, then the setup, it sets the initial condition of the peripherals that are connected, and there is a loop which infinitely calls the function that you will be using in your execution or in your board. So let's get to the previous slide once more. You can see that there is a void setup. In this part, we initialize the condition of the peripherals, that what will be the condition of my sensors or all my pins at the very moment when I start my board. Then the control comes to this void loop part. In this part, the thing is that it goes on repeating the commands that you have written for infinite number of times, until and unless the program is not closed. So it has been made very simple for use. This is one of the program that is called as the Hello World program of electronics world. It is the blinking LED program. As I have said that in void setup, it initialize the digital pins or initialize the pins that are there. So it's the syntax of initializing this pin as output. It is a blinking program. So the pin is made output. So it is written as pin mode LED built-in, output. And in the void loop, the thing is written as what is going to be executed infinite number of times. So digital write, this is for writing, or this is for making the that pin high. That means 1. It will bring the LED, it will glow the LED for 1 second, and then it will again change the condition, it will make it 0, and it will stop glowing, and this will happen continuously until and unless the board is connected or power is given to the board. So this is how a program actually looks like. This is the structure. It is very simple. You can, when you're seeing a very large code, you first go into this void setup, very large Arduino code. Just go into the void setup and see what is getting initialized and what is the initial condition of the peripherals. Then you go to the void loop and see what function it is calling and what commands it is executing. And it really creates a picture in your mind about how the whole program is running, and it really makes the whole thing easier. Whole thing easier. Recently I was doing a code. It was a very large code, and I was not understanding what it was actually doing. So the first thing I did was looking into the void setup, the initial conditions of the peripherals, then the void loop, then the void loop, the commands that are being executed a number of times. Then I made a chart, and it was really simple doing it. Here I'll show you one thing. That is, you can do this simulation of this Arduino inside application called Tinkercad. You can go to this website tinkercad.com and can create your account there, register yourself there, and you just you can get here uh, many electronic components that you can use to simulate. So here I have used this to show you a simulation of this blinking LED sketch. Here you can see that it's a code part. Here you can write the code that I have shown in that slide. You can write any code here, and you can then just start. You can click on start simulation to see the simulation that is happening. This code you can also use this. Okay, it will get clear. Okay, let's see. Hmm. You can also use these things to set your logic. See, here is a part that it is telling set build in LED to high, then wait for 1 second, set built in LED to low, then wait for 1 second. This is a blinking sketch in using block diagrams. So here are many outputs, then there are inputs, then control, then you can use this math, these conditions whenever where you used, then you can create the variables that you can use in your code. Can you see this blinking thing that it has started the simulation?
Yes, sir.
Okay. This is how you can do the simulations here in tinkercad.com. You can just logging here, register, and you can do many stuffs here. There are many components you can use from here. See, there are DC motors, servo motors, then transistors, RGB LED, this thing, photoregister, that was I was talking about few minutes back. This photoregister, you can use it to find the intensity. Then PIR sensor, this is used for detecting motion. And I'll tell about this PIR sensor detecting motion and sending alerts to your mobile device using Wi-Fi. This is the ultrasonic sensor which can measure the distance in front in distance, and can be used in cars like obstacle avoider car. Then there is a temperature sensor. You can see that you can understand the temperature and can use it in many projects, many real life project. You can use this temperature sensor uh, and can switch on or off your AC or something fan like that. You can do that. This piezo is the buzzer or the sound that it produces sound. It also has multimeter to check the voltage, current, anything. So this is really a very good place to do simulation, to do basic simulations. Just you need to do this, just tinker around with all these things.
The code that you had written.
Hello.
Hello.
Hmm.
Yes, sir. While joining one of the device that Lisa, you have written given one code there.
Hmm.
Sir, for every means I want to say that for every different devices there will be different kinds of code, right?
Yes. But the structure is same. Actually, structure is same that I told about void setup and void loop. The structure is same, and the commands that you will be using are same. Because let's say you are using a photoregister. What you will do? You will use a thing called a command called analog read. It will read the analog voltage from that photoresistor, and it will convert it into uh, digital output, which can be processed by the microcontroller. Like this, you have to change accordingly with the sensors that you use. But the structure is same. Like for LED you used digital write comma output. But sometimes, let's say you are using let's say you are using of alarm of, let's say, fire detecting sensor. Okay, now you will write that digital write digital write pin comma input, because the fire sensor will give you input of 0 and 1, seeing by checking that there is fire or not. If there is fire, it will give 1. If it is not, if there is no fire, it will give 0. So you have to change like this, but the actual structure or the whole thing remains the same.
So while practicing in that tinkercad.com, we will not get that code, right? Means we have to give that from outside, give that code from
Yes,
outside.
yes, 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 yes. You have to write the code. In Tinkercad, the default it is there is the LED blink code. It is defaultly given there. If you use an Arduino in Tinkercad, when you will see the code, you will see that there is a default LED blinking code there. But if you want to use something else, you just need to change the code like that. The thing that you want to do, you will have to change like that.
Okay, sir.
Is it okay?
Yes, sir.
Okay, sure. Mm. This is the thing that I want to just show you people. Like, I have done so many things in Tinkercad. It is very good simulation software. Like, I have used it a many lot of number of times, doing many things. So you people also can use this software to do use this application to do the things. So this thing I have covered a little, but let me tell you just once again what we can actually do with this Arduino board. We can use sensors to sense the environment, or we can use actuators to perform an action. Actuators are nothing but the things which can change the environment, like change the surrounding. Sensors can sense the environment, and actuators can change the environment. So sensors like motion detection sensors, fire detecting sensors, photoregisters, thermistor for measuring temperature that I have shown, ultrasound sensor. There are many more sensors. Like recently, I am using a capacitive touch sensor, um, which can sense the touch you give to that. And in the actuators part is the thing that actually change or perform an action, like the motors, like the relay switch, which can switch on the fan if the temperature is high, like that. So if you consider project of temperature sensor, like there is a temperature sensor connected to your microcontroller, and you have a relay switch connected to your microcontroller and to your fan. So here the temperature sensor will sense the environment and send instruction or send data to the microcontroller board. Now this microcontroller board will process the information and will send instructions to the pins, output pins or the relays to switch on the fan. It happens like this. This is the actual work of the actuators. The speakers is also falls under actuators. The buzzers or the display LEDs, LCDs or LEDs, they are also falls under actuators. The servo motor, which is one of the most important thing in bionics or robotic arms or cranes like this, they are also an actuators, and they are really very useful in doing very significant in doing this robotic arms project, and also in general robotics project. They are very significant. Okay, if anyone have any questions, you can ask on today's webinar, or just let me just summarize the whole thing that we learned today, and also the agenda for the next session. Okay. I think there is no questions, I guess. Then, so from the very beginning, let's start from the very beginning. We got to know about Arduino, what is a microcontroller, their various specifications. Then we got to know about various Arduino boards, their usages, their specific number of pins. We learn about Arduino Uno in details, got some good idea about Arduino IDE and the programming structure that Arduino follows. And now it's time, and now it's up to the it's up to you that to do further research on this topic, so that you get some good idea more about these things. I guess in our next sessions, I'll be telling about these analog sensors, these ADCs, analog to digital converters, how actually Arduino processes these voltages and converts them into digital, in outputs or inputs like that. I'll show that actual bit resolution or the structure or other things that is there inside, that is happening inside ADCs, or to convert this voltage to digital outputs. We'll program with this Arduino IDE, and I'll try to show one project using these analog sensors. Hello, anything?
No, Akash, you can continue.
Okay. Hmm. So this was it for today's session. I think there is no question. If someone asks, they are good to go. But I think there is no question.
You all can write in chats if you're not comfortable to unmute yourselves, or if you want him to show something that you didn't understand, like anything. It's not like you. If it even if it's feel if, even if it feels silly, you can ask. There's no problem in that. I guess no. Okay. Do you have any other simulation to show so that they can get an idea, like
I have
how?
I have not used the code. I have not tested the simulations. I have the simulation, but I have not tested them. But
अच्छा,
mm,
okay, ठीक है. Or do you want to show them anything that you've made already? Is anything at the moment working that you can show them because we have time?
okay, okay. Just let me. I'm stop sharing and again.
Sure. Do the setup. Let's just wait for 5 minutes. If you want to ask anything, you can ask. Till then, let him set up and let him show something that he's done already using Arduino so that you can get to know how
Uh,
to use it.
One thing you people can say that I have shown the blink LED.
Mm-hmm.
No, no, 1 second.
Okay.
Uh, this thing, you can see that I have done this blink LED code using 2 lines of code. Can anyone think of doing it in 1 line or without using delay? This thing actually delay, what it does, it stops the whole function of the programming. Let's say you doing a multitask, you are doing various tasks at a time. Now if you use delay in your program, what it will do, it will stop the whole system, whole microcontroller processing, and it will do this thing only. So this is very much very bad for the program or bad for execution when you are working on some multitasking work. So can you think of doing anything like without using delay? I'll tell about this after I show this. Is it visible?
Yeah, it's visible, Akash.
Okay. This one is the obstacle avoider card that I had made few months back.
And how did you make it? Can you explain the process to the people? Like, what did you use
Yes,
and
yes,
what was your approach?
yes, of course. The thing is that what I did, it can you can see that there is a ultrasonic sensor in front of it that I had told uh, in my slides. This ultrasonic sensor, it measures the distance. Now it sends the info, the data that it collects to the microcontroller or the Arduino. Now what Arduino does, Arduino processes the information. It checks whether the distance is less than something. If the distance is less than something, then it just send commands to the actuators or the motors to rotate the direction, to move in some other direction. That is the main concept. The whole that the thing I told, that sensor and the actuators. This is the full project of that, using that. Sensor is the ultrasonic sensor that I have used, and the actuators are the motors. And the brain of this whole project is this Arduino. Let me show one more project. Hmm. Is it visible?
Yes, Akash, it's visible.
Okay, okay. Hmm. Hmm. This is the project that I had made for this. It was a COVID supply sanitizing bot like that. It,
Okay.
it if you keep a hand in front of it, it will stop and supply the sanitizing things like that. But and it also has a camera in it to so that it can
Okay.
stream the live video to the controllers. And
Okay.
yes, and it can follow certain lines. It can follow
Mm-hmm.
predefined lines, so that it will be very helpful in things like in hospitals or things like that. Very helpful and can provide sanitizing and other useful stuffs to them. The next thing that I want to implement in this is video processing, so that it can send alerts for social distancing in front. social distancing to the controllers unit. So this is the thing that I want to make implement in this.
Okay, that's great. So, looks good to us. Like, anybody wants to ask anything, or should we conclude the session now?
And
Yeah.
that's the thing that I was telling about, that
Mm-hmm.
blink one, doing it in
Mm-hmm.
one line and not using delay. This is the code for doing it in one line. What you will do is that you just use this operator, negation operator, and digital read the lead building. If it is 1, it will just convert it to 0, and it will write that pin 0. And again, it will, after 500 millisecond, it will like read the pin. If it is 1, it will invert and it will change to 0, and it will write that to that pin. So in this way, it can blink, and it's just a programming trick to do it in one line. And for that, without using delay, is that you have to use one function called millis. What it does, it 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 measures the time from which the actual program has started. So what you will do, you will take a variable, let's say start. Start is equal to millis. You will hold the time in that start variable, and another variable you will use as previous. Now, if the start minus previous is greater than the interval of blinking, then you will uh, change the LED to, if it is off, it will be put to on, and it is on, it will be put to off. In this way, what is the most advantage is that it does not uses delay, and it does not halt the whole program. It just gets the value or gets the time from which the program has started, and it checks whether the interval is greater or like that, greater than a certain interval or not, and it can just convert it to the it just toggles the LED. It does like this, it functions like that, and this is very useful. And when you will do more programming of multitasking, you will understand in more details. Like when I did the project of a robotic crane with servos, I needed multitasking servos. So at that time I needed this thing, or else this one servo was running and other was just getting stopped. So this is really a very useful thing, and I think more research will give on this. Millis will just make it more good. So that was it from me. Thank you everyone for joining.
We'll wait for another 5 minutes, and then at
Okay.
7 we can conclude the meeting. Like, whoever wants to ask questions, they can stay. The rest can leave.
Excuse me, sir.
Yes.
Sir, can you, like the way you shown it, means can you suggest any kind of videos or any kind of thing from where we can learn it? Means we can get to know something about it.
Yes. I'll say that YouTube, there is a lot of tutorials on YouTube on Arduino. You can check there, because Arduino is very popular board, and there are a lot of tutorials over there. And I have mainly studied from there, and you can also do some courses from Coursera, which is, or Udemy. They are very good on these microcontrollers, Arduino.
Okay, like
They
the
are
way
also.
we do for Python and Java, like there are also courses for this Arduino, right?
Yes, yes, yes. There are many courses on Arduino. You can prefer them. You can learn from them. Yes, and the most important thing is that not doing the course. The most important thing is by do it in hands-on, doing it in real life. So that's the thing. I have seen many people doing the courses and doing lot of stuffs, reading books here and there, but they don't do anything. But that's not the thing. Making things hands-on is really teaches a lot as you go.
Cool. Then this is the end of today's meeting. I guess everybody is from the team, right?
Yeah.